All right, hello, Algebra 1, back here with you. Still working on some polynomials. Okay, now we're doing everybody's favorite, some big fractions. We're going to be dividing these polynomials, okay? Don't worry, these aren't as scary as they look. I know they look like huge fractions, but they're not too bad. We're just going to break them up, okay? Just to review though, just again, there's that exponent rule, okay, from that earlier video that talks about that rule where when we're dividing things with exponents, how we can deal with those exponents, okay? And again, let me just write my saying you can kind of say to yourself as you go through these problems. Okay, so here's your rule that you say to yourself. You say divide the big numbers, and that would be these coefficients. Okay, these coefficients, these numbers in front of the variable, we actually divide those numbers like normal. Okay, but then our exponent rule says that we subtract the little numbers, or those would be the exponents. Okay, so whenever we're dividing, there's a variable with an exponent on the top and on the bottom. The shortcut is to subtract those little numbers, right? So if I did that for this first one, if I followed this rule, okay, we could do, again, divide the big number. So 12 divided by 6 would be 2, right? So that would result in a 2 as a big number out in front. And so it would be 2x, right? So there's x to the fourth, and then there's the single x. And again, that single x is going to have a 1 exponent, okay? So x to the fourth divided by x to the first, subtract the little numbers, okay? So it would be 4 minus 1, 2x to the third. Okay, so that's how we would subtract those, okay? And that'd be my answer to this, okay? Another way you could think of the variables here, again, I talked about this in that exponent rule video too, but again, with just the x's, if I expanded x to the fourth, right, that would be saying x times x times x times x, right? 4x is multiplied. And then on the bottom here, x to the first would just be 1x, okay? So essentially what's happening is I'm dividing x divided by x, and that cancels, right? And I have 3 x's remaining, okay? So that's another way you could think of it too. For some kids, it really helps them to kind of expand and draw out all the variables. So if that helps you, please do that, okay? And just one more example of a single one, right, when we're dividing by a single term, and then we're dealing with these big groups, okay? So this next one says 40 x y to the third over 5y, okay? And again, something that's helpful to do. Whenever you see these variables that are just by themselves that don't have an exponent written, just include the one exponent there. Okay, just write those in. So yeah, write in these one exponents here because that helps you to remember how many of those you're subtracting by. Okay, so again, follow this rule. Divide the big numbers, subtract the little numbers. So 40 divided by 5 would be 8. Okay, and then x to the first, what I would try to divide by there is if I had x's on the bottom, okay? And I don't, right? Because we can only divide things that have the same base or the same type of variable. Okay, so here I don't have that. And so it would just be x to the first divided by nothing. And so it would just still be x to the first. Okay, so that would just stay the same. And then y to the third divided by y to the first, again, subtract the little numbers. So I would have 3 minus 1 would be 2, or y squared. So that would be the answer there, 8x to the first y squared. Okay, just that single term. Okay, this rule is still going to apply for my big groups here. Okay, but let's talk about these because these are, again, bigger groups. I'm going to be dividing a lot of different things here. Okay, so this is saying 10x to the fourth plus 16x to the third plus 22x squared over 2x squared. Okay, so what's happening here is I have this whole polynomial, this whole group of terms divided by a single term. Okay, and so basically what this is saying, what I do here is, okay, so basically what's happening here is you divide every term in this top group by the 2x squared. Okay, so it's basically going to be 3 separate divisions that happen. It's going to be 10x to the fourth divided by 2x squared, 16x to the third divided by 2x squared, and then 22x squared divided by 2x squared. Okay, so three different divisions happening here. Okay, and what can help too is if you kind of write out those individual fractions. So this first one, says 10x to the fourth divided by 2x squared. Okay, so I would again follow this rule: divide the big numbers, subtract the little numbers. Okay, so 10 divided by 2 is 5. x to the fourth divided by x squared. So subtract the little numbers. 4 minus 2 is 2. So when I divide this first term by 2x squared, I get 5x squared. Okay. And then my second fraction, 16x to the third divided by 2x squared. Same idea, right? So it'd be 16 divided by 2 is positive 8, right? And then x to the third divided by x squared. Again, subtract the little number, so 3 minus 2, x to the first. Okay. And then my last one, so 22x squared over 2x squared. So again, to divide the big numbers, 22 divided by 2 is 11. And then x squared divided by x squared. So I would have 2 minus 2 is 0. So you could write x to the 0. Or basically, like if I wrote it like this, what's happening is I have 2 x's on top, 2 x's on bottom, and they kind of both cancel each other out. So when this happens, basically all your variables are gone. And so you don't need to write that. You could just write 11. Okay. So that would be it. That would be dividing this whole group by the 2x squared. Okay. So you see it's kind of 3 mini divisions within this big fraction. Okay. Cool. Let's look at a couple more. Okay, so looking at number 2 here, I have 26x plus 39 over 13x. Okay, so let's talk about this. So again, I can split it up. I can say 26x over 13x, and then that second term plus 39 over 13x. Okay, so for this one, again, I divide the big numbers. So 26 divided by 13 would be 2. Okay, and then x divided by x, again, those would cancel. You could write in the 1 exponents as well, but 1 minus 1 is 0. So this would just be a 2 here. Okay, just a 2. And then plus, the second one's going to be interesting. Okay, so it's 39 over 13. So I can still divide the big numbers to get 39 over 13 is 3. Okay. And then look at the x's. Okay, I have no x's on top, but I have an x on the bottom. So there's a couple ways you could write this. Okay, so you could think this is saying x to the 0 power. You can always kind of add that in because x to the 0 power would be equivalent to 1, and so you could add that in there. So what you could do is just think, okay, there's no x's on top, there's an x on the bottom, so that x is going to have nothing to cancel with. So that x is going to stay there, but keep in mind that it's on the bottom of a fraction. Okay, so I'd have to write this as 3 over that x that stays on the bottom. Okay, so it's kind of weird, but the positions of whether something's on the top or on the bottom of a fraction is really important. Okay, but that would be how we could write that. So 2 plus 3 over x. Okay, so that's that one. Okay, so just keep in mind how, like, if there's more x's on the bottom than on the top, you're going to have to write that a little bit differently with those x's still on the bottom of a fraction. Okay, looking at number 3 here. So x to the third, y to the fourth, minus x, y to the fifth. Again, as I read through this, if I see any variable without an exponent, I'm just going to put a 1 there. And then plus x to the fourth, y to the third, all over x to the first, y to the third. Okay? So I have all that. And so again, I could, if it really helps you to break it up like this, I know a lot of kids do that, then please do. Okay? Just because honestly, because I don't have a lot of room, I'm just going to kind of go and without doing that. Okay? So, but it's just this first term divided by this. So x to the third, y to the fourth over this term. Okay? So x to the third, again, and within this, just this term over this term, there's 2 variables. So I kind of go x's first and then y's. Okay. So x to the third divided by x to the first. Again, and what's with this one too, there's no big numbers out in front, right? None of these have big numbers. So I can kind of skip this step and just, I'm thinking, okay, this whole time I'm going to be subtracting these exponents. Okay. So x to the third divided by x to the first, 3 minus 1, x squared. Okay. And then the same term, y to the fourth divided by y to the third. So 4 minus 3 would be 1, right? Subtracting those little numbers. Okay, so that's my first term. My second term. Now keep in mind that this is a minus, okay? So I'll just keep it as a minus because that sign is going to stay the same for this one, okay? So I would have x to the first divided by x to the first, and I could do 1 minus 1. So you could say x to the 0, like I said. Or again, oftentimes you won't see the x to the 0. You'll just think, okay, those terms kind of cancel each other out in that term. Okay. But then it's y to the 5th divided by y to the 3rd. So 5 minus 3 would be y squared. Okay. Then my last one, I have positive x to the 4th divided by x to the 1st would be x to the 3rd. Okay, 4 minus 1. And then y to the 3rd divided by y to the 3rd. So 3 minus 3. Again, you could say y to the 0, or again, oftentimes we don't see that written. Okay, and that's it, right? And there's no like terms in here to combine either, right? So I can just write it like that. So there we go, there's number 3. Last one, number 4, okay? Again, same idea, I won't break it down like I did the other ones, but again, if that helps you to break it up into individual fractions, do that, please, okay? So 18x to the 4th divided by negative 9x squared. Now keep in mind this is a negative, okay? So now I divide the big numbers with this negative. I'm going to have to switch around the signs a little bit, okay? So it's going to be 18 divided by negative 9 is negative 2, okay? And then subtract my little numbers. X to the 4th divided by x squared. 4 minus 2 is 2, okay? Now this next one, negative 63. Negative 63 divided by negative 9. So negative divided by negative is a positive 7, right? So that'd be positive 7. And then x squared divided by x squared. So 2 minus 2 is 0. Or again, we don't have to write the x's there. So that would just be plus 7. Okay. Then this last one, 81x divided by negative 9x squared. Okay. So positive 81 divided by negative 9 would be negative 9. Okay. And then again, kind of same as up here, x divided by x squared. So again, what's happening there, 1x on top, 2 x's on bottom. So one of those x's cancels, and then there's 1 left over. Okay. But that 1 that's left over is on the bottom, so we wouldn't say just 9x. We would not say that. We would say 9 over x, because again, that x that's left is on the bottom of a fraction, so we have to keep it down there. Another way you could think of this is, and this would technically be correct too, right? If we subtracted, we would be saying 1 minus 2. So you could also say this last term is negative 9x to the negative 1st power. But again, we didn't talk about negative exponents yet in this unit. So yeah, if you write it this way, that's not incorrect, but this is the preferred way to say 9 over the x, okay? But if you write it this way, that's not wrong either. So guys, I hope that makes sense. That's dividing polynomials, okay? Pretty quick lesson here, but yeah, hope you get the concept. So thanks for following. Good job.